In this lesson, we're going to talk about scientific notation. Specifically, we'll understand scientific notation, we'll be able to convert numbers written in standard notation, a regular number, to scientific notation, we'll be able to convert numbers written in scientific notation to standard notation, and then we'll learn to multiply and divide numbers written in scientific notation. So to get started, what is scientific notation and why do we have it? You may recall that it's a number times 10 to some power, and we'll get into the proper or specific form later on. But really, this is a way to represent really big or really small numbers using powers of 10. This makes comparing those numbers that are really big or really small easier, and arithmetic like multiplying and dividing easier as well. So just a couple fun facts using numbers written in scientific notation. The speed of light is about 6.7 times 10 to the 8th miles per hour. You can fit approximately 1.8 times 10 to the 23rd basketballs inside the Earth. And the radius of an atom, the building blocks of everything, is 3.9 times 10 to the negative 9th inches. So review of exponents using powers of 10, because this is going to come up later on. And we'll start here at 10 to the first power. 10 to the first is just 10. 10 to the second means 10 times 10, which is 100. 10 to the third means 10 times 10 times 10, which is 1,000. 10 to the fourth, just a 1 with 4 zeros. Okay, so that's going up in powers of 10, and going the other direction, remember anything to the 0 power is 1. 10 to the negative 10th is 1 over 10, or 0.1. 10 to the negative second is 1 over 100, or 0.01, and 10 to the negative third is 1 over 1,000, or 0.001. Okay, so a couple of things to notice here is that negative exponents cause us to think about fractions, or in this case, decimals might be more helpful for what we're doing. And also, these powers of 10 relate to scientific notation, and they also relate to place value. The ones place, tens place, hundreds, thousands. 10 to the fourth is the 10,000s place. 10 to the fifth is the 100,000s place. 10 to the negative 1 is the tenths, etc. So that's why we're going to use powers of 10 to convert numbers in standard notation to scientific, because it relates to place value, or where those numbers would be anyway. So scientific notation continued. So these two examples, 7.2 times 10 to the fifth and 3.4 times 10 to the third, are examples of numbers written in scientific notation. 7.2 times 10 to the fifth means 7.2 times 100,000. Okay, and I'm getting that 100,000 from the chart we just made. 3.4 times 10 to the negative third means 3.4 times 0.001. And we'll do the math on these numbers a little bit later on, but this is just to show you that these two numbers are written in scientific notation. So the proper form of scientific notation, make a star by this, is it's a or some number where a is between negative 10 and 10, probably not, hold on. Where a is in between 1 and 10, 1 can be included, 10 cannot, or it's in between negative 1 and negative 10. So essentially, when we're talking about a, there has to be one number to the left of the decimal point. So for instance, this has to be 7.2, not 72 or 0.72. Okay. Same thing here, this has to be 3.4, not 0.34 or 34. And then it's to the power b, where b is an integer. So positive 1, 2, 3, 4, etc., or negative 1, negative 2, negative 3, negative 4. So converting numbers written in scientific notation to standard notation, I have multiple sets of directions there just because it could phrase it in your homework in any one of those ways. So 9.3 times 10 to the fifth, there's a couple of ways to do these problems. You can write 9.3 times 10 to the fifth and put this in your calculator to get 930,000. Or one way that you could do it that you may have learned before is to write 9.3 and then times 10 to the fifth. Since this number is getting bigger, we're going to move the decimal to the right. 1, 2, 3, 4, 5, and fill in any of our loops with zeros. So I do my loops pretty big, so I make sure that I fill in enough zeros. So this becomes 930,000. Okay, so either way you do this will work. Part B, 3.1 times 10 to the negative fourth means 3.1 times 0.0001, which if you put in your calculator, you would get 0.00031, or we can do our loop-de-loop to get the zeros in, and we would be moving the decimal to the left to make sure that this number is getting smaller. 1, 2, 3, 4. So this becomes 0.00031. So either way you do it, you get the same result. The one thing I forgot to mention on the last slide is positive exponents mean really big numbers and negative exponents mean really small numbers. So before you start converting numbers, you can think about whether the number is going to be getting bigger or smaller. Part A, since the exponent is positive, it's going to be a bigger number. Part B, since the exponent is negative, it's going to be a small number. Going the other way, convert to scientific notation. So the numbers you see here, at least for A and B, are called standard notation, a regular number like we're used to seeing, and scientific notation involves powers of 10. So when we're converting to scientific notation, what we're going to do is see how many powers of 10 we need, or we're going to move the decimal that many places over. So we have 11 million, okay? And now what we're going to do is we're going to stop the decimal in between the 1. There can only be one number to the left of the decimal point when you're writing numbers in proper form of scientific notation. So for instance, we can't stop here as 0.11 and we can't stop here as 11. So let's go. Oops. 1, 2, 3, 4, 5, 6, 7. So this is 1.1 times 10 to the 7th power. You can plug this into your calculator and confirm that 1.1 times 10 to the 7th is the same as 11 million. And again, I'm going to write this in a different color. We couldn't do something like 1, 2, 3, 4, 5, 6, 7, 8, like 0.11 times 10 to the 8th. That although you'll get the same result as 11 million, this is not proper form of scientific notation. For part A, we should expect our exponent to be positive since we're dealing with a large number. Moving on to part B, we should expect our exponent to be negative since we're dealing with a small number. So we would move the decimal and we were going to stop in between the 5 and the 6. 1, 2, 3, 4, 5, 6. So this is 5.6 times 10. Don't forget it has to be to the negative 6 since it's a small number. For part C, 95 billion, when we have big numbers like this written in millions, billions, trillions, etc., write it in standard notation first, then convert to scientific notation. So 95 billion, I always count down when I'm doing these. So 95, so this is billions, millions, thousands, hundreds. Okay, so it's a 95 with 9 zeros. Now we're going to convert this number to scientific notation, and we're going to put the decimal in between the 9 and the 5. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 9.5 times 10 to the 10th power. Multiplying and dividing numbers written in scientific notation. So remember the rules of exponents that we've talked about. When we multiply bases with exponents, we add the exponents together, and when we divide bases with exponents, we subtract the exponents. So a couple things to keep in mind as we're multiplying and dividing numbers written in scientific notation. So you apply the given operation to the number in front of the 10. So whether you're multiplying those two numbers on the outsides of 10 or in front, or dividing them. And then you use the exponent rules for the powers of 10 and make sure your answer is in proper form of scientific notation. So example 1, perform the operation and write your answer in scientific notation. Part A, 8.4 times 10 to the 8th, and this is multiplication 3.6 times 10 to the negative 5th. So what we're doing with this one is we're going to multiply 8.4 and 3.6 because those two numbers are being multiplied. Okay. And then we're going to have times 10, and to determine the power of 10, since our operation is multiplication, we're going to add the exponents. Okay. So we're going to take 8.4 times 3.6, and we get 30.24. Switch colors here. Times 10, 8 plus negative 5 is 3. And then we check, is our answer in proper form of scientific notation? Well, no, in this case it's not, because there's 2 numbers to the left of the decimal place. So we have to move the decimal over 1 to the left, which means that the power of 10 is getting bigger. So we move it to the left and we add 1 to the power of 10. So this is 3.024 times 10 to the 4th power. And again, you can always use your calculator to double check that these 2 numbers are the same. Your calculator will also do these problems as well. I'm not sure if it'll put it in the correct form, but you can put these in your calculator exactly how it's written. Part B, dividing. 1.3 times 10 to the 20th divided by 1.8 times 10 to the 3rd. So we divide 1.3 by 1.8 because of the division in between. So 1.3 divided by 1.8, and then times 10 to determine the power of 10. Since we're dividing, we subtract the powers. Okay, so we put it in our calculator, 1.3 divided by 1.8. This number goes on forever and ever. I'll just go to, let's say, 3 decimal places. So we have 0.722 times 10 to the 17th. And then we check, is this number in proper form? In this case, it's not. We need to move the decimal to the right 1 spot. So we're going to decrease the power of 10 by 1 to become 7.22 times 10 to the 16th power. Okay, so note, when you move the decimal to the left, you add 1 to the power of 10, just like we did in part A. And when you move the decimal to the right, you subtract 1 from the power of 10. If you have any questions, please feel free to reach out to me.